Good day everybody, this is Mikal Patrick K. Deiparine and I will discuss to you constitutional isomers. So what are constitutional isomers? Constitutional isomers are compounds with the same molecular formula but different connectivity of their atoms. An example of this would be C4H10, which is butane 2-methylpropene. But if you count their carbon atoms, they'll have the same value. You count here. 1, 2, 3, 4. 4 carbons. How about the other one? 1, 2, 3, 4. There is 4 carbons again. And if you count the hydrogen bonds, there is 3 here. 1, 2, 3. 2 here. 1, 2, 1, 2, 1, 2, 3. So it's about 10. How about the other one? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So they are the same molecular formula but different connectivity of atoms. Another example of this would be the molecular formula of C4H8O. Here, tetrahydrofuran, 2-methylpropanoldehyde, butanol, butane, and many others. And before we move on, we should know how to solve constitutional isomers so that we could understand much more better. So this would be example 1. You can find this on your worksheets, your lecture notes on the Masawa LMS. Anyway, let's continue. The structural formulas in each of the following sets represent the same compound or constitutional isomers. Strategy of this would, number 1, find the longest chain and number it, and 2, compare it with the other constitutional isomer. Okay, let's start to count. 1, 2, 3, 4, 5, 6. There's 6. How about the other one? 1, 2, 3, 4, 5, 6. They have the same number of carbons. And if you look at the other one, it's still a chain. It's still the same. So they have the same number of carbons. How about the connectivity? This one is straight line. How about the other one? On the third one, it goes down. But should remember, since there is no substituent within the second one, then this is the same as the first one. It's just drawn differently. Anyway, the second one, or the second example. Let us count how many carbon atoms there are. 1, 2, 3, 4, 5, 6, 7. How about the other one? 1, 2, 3, 4, 5, 6, 7. Oh, they have the same amount of carbon atoms. But let us look at where the substituents are placed. If we look at the substituents at the second carbon and the fourth carbon has the substituent. How about the other one? 1, 2, 3. Substituents are found in the 2 and 3. So, because of this, the alkanes are unfortunately not the same, though they are constitutional isomers, yes. Another example is draw line angle formulas for the 5 constitutional isomers with the molecular formula C6H14. Strategy here is first, draw a line angle formula for the constitutional isomer with all 6 carbons in an unbranched chain. Then, draw line angle formulas for all constitutional isomers with 5 carbons in a chain and 1 carbon as a substituent. And finally, draw line angle formulas for all constitutional isomers with 4 carbons in a chain and 2 carbons. If you want to answer this, feel free to pause the video. If you pause the video, very nice. Anyway, these are the solution. If you answered correctly, good job! Nice one! Anyway, let's continue. Here in the table, we can see the molecular formula with their corresponding constitutional isomers. And as we can observe, as the amount of carbon atoms increases, their corresponding constitutional isomers also increases. Thus, for even a small number of carbon and hydrogen atoms, a very large number of constitutional isomers are possible. In fact, the potential for structural and functional group individuality among organic molecules made from just the basic building blocks of life, carbon, hydrogen, and nitrogen, and oxygen is practically limitless. Thank you for listening to my report. Remember, practice makes perfect.